Hey everyone, Mr. Anderson one more time with section 7.2.1 from our CPM Common Core Algebra book. And today we're going to talk about how we can take a exponential function and really come up with an equation for that function. How can we formalize it? How can we take a curve and come up with, or a graph, and come up with an equation for that graph? Because remember, some of the things we've talked about are graphing allows us to make a prediction or an estimation, whereas an equation can give us a certain precision or exactitude that a graph can't provide. We're going to get started today talking about how we would do this with a linear function, right? Something we have some experience with, and then we're going to see if we can translate that into an exponential function. And then finally, we'll talk about this thing that it says right here, and fractional exponents. What happens when we get a rational number written as a fraction in our exponents? How can we use some strategies of exponents that are really going to make that easier to deal with, or even more strategic to deal with for the purposes of problem solving and manipulating. So here we go. I've set up some notes and you guys can see these here in number 7-79. We've got an equation of a line in slope-intercept form here with a slope of 3, and it passes through this point. And we're going to go ahead and write the equation of the line, right, having these characteristics. And it says take careful notes. What we're going to do is just pay attention to some of the things that we're doing, and we're going to do some solving. All right, I'm going to use what they ask me to use here. I'm going to use the slope-intercept form equation, y equals mx plus b. And I'll remind you that we can just start by subbing in the slope, right? The slope goes in for m, and so far we're running clean, okay? But the next thing that we know is that this is the x-coordinate, this is a y-coordinate, and the line goes through that point. That means that my equation needs to hold up with that x and y in there. Okay, well that's actually not too bad. That means I plug in 19 for y. It means I take 3, and then the 3 from before, I plug in 5 for x, and then of course plus b. Now what have I done? I've taken this and I've reduced this all the way down to a single variable equation. Okay, well, that's actually not too bad. 3 times 15, okay, 15, and okay. Now I subtract 15 from both sides, I get b equals 4. Okay, well, I'm looking pretty gosh darn good so far. I don't have the equation of a line, but I do know what m is, and I do know what b is. And now I can take just a second, I can rewrite with m and b in there. Okay, notice I've left x and y in. I do have an independent and dependent variable. When I go ahead and use my calculator or my Desmos, I will be able to graph this, and that graph will represent the relationship between this x and y. Happens to be a linear relationship. Okay, so we've used strategies like this. Now let's see how it can apply to an exponential. And some of the things I'm going to talk about right now are things that we've laid the groundwork for in prior videos. So if you haven't seen some of those, go back and watch. All right, but then let's see if we can take this strategy right here from 7-79 and apply it and make some progress with exponentials. Okay. In 7-80, it says, can you use a similar idea to find an exponential in the equation in the form of y equals a times b to the x? All right, well, we've got a graph, right? Here's my graph that is given to me, and there's some information in the graph. We see a y-intercept, we see another point. Now, prior videos have me demonstrating a method for how to write an equation for this in what might be a pretty clunky process. Today, let's see if we can streamline that process and make it match something that we did in the prior problem. Well, trying to find the equation for the graph in part C of the problem, 7-59, shown at the right, arrow stated, I think A must be 7 because the y-intercept is 0, 7. Do you agree? Justify your answer. I'm going to go ahead and say yes, absolutely, we agree. That's our starting point. That's got to be our y-intercept. Remember, that happens when x is 0. And of course, if you have x is 0, b to the 0 is 1, And so the only thing, that's our multiplicative item, the only thing we're left with is that a value. So a does have to be 7. Okay, well, but we still don't know what b is. Errol noticed his teammate Sandy had an idea. I think that, and I had to rewrite this because my formatting didn't look great. I think that 56 equals 7 times b to the third. How did she get this equation? Well, she went ahead and took y equals a times b to the x power. She plugged in the 7 that we agreed for a, and then she took our 356, just like we did in the prior problem, plugged in the 3 for x and the 56 for y. So she came up with 56 equals 7, there's my y-intercept, times b to the third. Now check this out. The only thing we have left here, just like that linear problem we just tackled in 7-79, is we've got a single variable equation that we need to solve for b. This one we have to treat slightly differently because we don't have all of the exact same rules for solving. When it comes to an exponential, this might require a trick from, you know, the toolkit that we got to dust off, right? Okay, let's go ahead. It says if you haven't done so already, solve for b. Explain how you solve this. Well, we did solve this one in the last video, but let's remember we're going to go ahead and solve the way we've solved before. I'm going to zoom in. I'm going to write a little bigger. Let's recopy this. 56 equals 7 times b to the third. Let's start by getting rid of this 7 to isolate this b, right? And you guys saw me do this plenty of times, right? We've got 8, right? Because 56 divided by 7 is 8. Then the only thing I have left is this b to the third. Now I did drop my parentheses there, and the reason I can do that is because I'm no longer multiplying by anything, and there's not anything being added that's impacted by that exponent. So I've got 8 equals b to the third, and my question now is, how do I get rid of that third power? And we've got a rule or a way to do this that we might remember from some middle school math. We've got a third power. We can get rid of that third power with a root with 3 as the index. Now, just like before, if I do it to the left-hand side, I've got to do it to the right-hand side and vice versa. If I do it to the right-hand side, like I'm about to do here, I've got to do it to the left. Now, here's the beauty of this, and I'll work sideways. If I take b to the third and I have a third root, they cancel each other out. They're inverse operations. The only thing I'll have left is on the right, b. Okay? But now, ladies and gentlemen, let's talk about that thing on the left-hand side. That's the third root of 8. Now, do you remember from the prior video? That's a number times another number, that's the exact same, times a third number, that's the exact same, and that has to equal 8. Do you remember what that was? Okay, because that's what my third root is going to tell me here. Now I've got a calculator here that I can use on my iPad, right? MyScript calculator, if you don't know what MyScript is, it's a wonderful calculator. I can take 8, and I can take the third root of 8, and ta-da, 2, right? Probably saw that coming. Maybe you did, maybe you didn't, but here's my iPad back. This is telling me that my answer is 2, okay? It says use a and b to write the equation for this graph. Do you agree with the equation? Well, yeah, we're going to find that this is the exact same. I leave my x and my y in, and I can check this by having this reproduce the exact same 356 point, right? If I put in 3 for x, it will spit out 56 for y. All right, so that's going to work out, right? And that leads us into kind of what we're going to be doing here in 7-83. We've got a property of exponents that we remember from earlier this year. We've got the power to a power property, and it's going to help us do some rewriting. And the power to a power property just says, if I've got an exponent, I'll zoom in on it here because these are in variables. If I've got a power, right, k to the m power, and it's raised to another power, well, I can just rewrite that as the product of those powers. Okay, that's k to the mn power. And it works for rational, or as they're called here, fractional exponents as well, right? There's an example. They say 16 to the 3/2 power. That's 3 over 2. That can be rewritten as 16 to the third to the 1/2. That's because 3 times 1/2 is 3/2. Okay? We can also rewrite that with a radical. Here's my radical symbol, my root symbol. And the reason this one looks maybe a little peculiar is because that's a square root. And when we take a square root, it's got an index of 2. But it's so common that we don't often write it. If you did, nobody's going to fault you for it. But that's like saying the square root of 16 to the third power. Notice the third power is under the radical symbol. One more time. I can flip-flop those. We saw 3/2 to the, or 3 to the 1/2, right? But here's 1/2 to the third, because again, 3 times 1/2, that makes 3/2. And then finally, here's one more. We've got, 16 to the 3/2 power. We can rewrite that as the square root of 16 to the third. And this is super convenient because look at how nice this one works out to be. The square root of 16 is a known value. That's 4. I could also rewrite that as 4 to the third power. So there's just another way to do some thinking about some things. And trust me, if we know some of these strategies, it might behoove us and make us more effective problem solvers, right? And that's what we're going to be doing in some of these problems. I'm going to go through some examples. And it does say with your team. Obviously, in this video, you can't be working with your team. It's just me here, right? But you can pause the video and you can try to beat me to some of these some of these rewritings, right? Find ways to rewrite the expression 2 different ways. Be ready to justify your answers. Well, I'm going to show you guys a couple. And we're going to start with A here, and A is 10 to the 2/3. Now, a really easy way is to separate numerator and denominator, right? So we could write this thing as 10 squared, and then I could put that up to the 1/3 power. Okay? That works. It's going to work every single time. And notice what I did. I just plucked that numerator out, and I rewrote it with a numerator 1. It's like factoring. And then I got 1/3. Okay. Well, it's also going to work to do it like this. This isn't very exciting, right? It's very, very similar, not very exciting, but there's 2 different ways. Okay? And that's going to work. But I'm going to throw a third one at you because what I want to show, I'm going to go off of this one. What I want to show is a connection. All right? I can go ahead and I can take this 10 squared that I have inside the parentheses there. But this 1/3 power, this actually, let me use purple here, this actually means something important. Anytime, and I'll remind you of what we did earlier, anytime I have a 1/3 power, that's the same as a radical with an index of 3. Okay, so we've got, in this particular case, one way to rewrite this, a second way, and now we've got a third way. And you could probably even take this and maybe do that slightly differently, right? What if you did this? Huh? That's different, believe it or not. Okay? I know it looks very similar to number 3 there, but it's different. Let's keep going. Let's see what else we got. Here I've got the square root of 5. Remember, a square root is like having an index of 2 there. Okay? Well, then that's going to be the same thing as saying 2 to the 1/2 power. 1/2, I'm sorry about that. To the 5th power. That works. That works. Okay. That's going to be then the same thing. Maybe I want to rewrite this as 2 to the 5/2 power because now connect this. 1/2 times 5 is 5/2. Okay. So that's another way. Okay. Well, if I write it as 2 to the 5/2, well, could I change that? Well, sure. What if I did this? And I know what you're thinking. You're thinking, Anderson, that looks slightly different, but what did I change there? I changed something. I changed something. I'm going to get the same answer, but I changed something. All right. I'm going to go ahead and leave the rest of these, right? Because there's plenty more of them. There's B, E, C, and F, right? That are all available to you, right? The ability to rewrite and take a rational exponent and convert it into a radical with an index is super duper important. Like I said, in problem solving, right? To rewrite and make something convenient is going to be a super helpful thing for you. Folks, there's a tiny bit of review preview here for you. Not too much. Things we want you trying, things we want you asking questions about, and we want you doing this in a timely manner. So if questions come up, we can get answers to those questions and move on. Ladies and gentlemen, thanks you for watching. Have a great day.